Now, these deep interfractal networks in each neuron would be very useful for that neuron, but what we really need is a global collective effect over the whole brain. And for that, we need quantum effects. And when we go faster and faster into the terahertz, for example, we're pretty much into the quantum realm, and we go deeper into the quantum realm also. So we do get the possibility for quantum at these higher frequencies, at least, if not the lower one. So we need this quantum non-locality entanglement in many brain neurons for things like spatiotemporal binding, the unity of self, as well as zero phase lag, gamma synchrony, and so forth. So quantum properties are useful for consciousness. As I just said, cognitive binding, sense of self, zero phase lag, gamma, condensation, entanglement can solve these problems if they're possible in the brain. Also, agency, causal selection for like collapse of the wave function, causal selection of actions and perceptions as quantum state reduction, collapse of the wave function. For example, to trigger axonal firings, as we showed in the previous slide, it's not just the membranes. Non-computability, as Roger Penrose argued from Gödel's theorem, you need some kind of quantum mechanism. The hard problem of phenomenal experience as an intrinsic feature of fundamental space-time geometry. For example, Penrose objective reduction, meaning that consciousness and qualia are fundamental aspects of the universe. Free will, real-time conscious action dependent on quantum backward time effects, retroactivity. Libet showed this in his 1979 work, and Roger Penrose has written about this, including recently. And also non-locality, parapsychology, out of life, even afterlife and reincarnation are possible. I'm not arguing for them. I'm not claiming any evidence. A lot of people are. You can't rule them out until we know what consciousness actually is. If somebody can prove that it's a classical thing, then these things are impossible. If it's a quantum thing, then they are possible. So this gets us into the quantum world, and the best way to explain it that I can see is with the yin-yang, where the world is divided into two realms, and the classical realm, everything is predictable, localized, particle-like and large, but in the quantum world, we have quantum superposition, non-local, wave-like, and small, and things are completely different. And I think consciousness actually is on the edge between the quantum and classical worlds. If you think that consciousness causes collapse, that would be going from the quantum to the classical, or if quantum is collapsing, the collapse is happening on its own to give you classical, and the same thing. In any case, consciousness is on the edge between the two. So in quantum superposition, a particle can exist as a wave of multiple possibility in the background or in the foreground as a particle in definite states or location. But when we make a measurement or an observation, it seems to cause the wave function, the waves, to collapse to particles in definite states. And this is the measurement problem in quantum mechanics. Now, Roger Penrose addressed this. He first addressed the problem of superposition. How can things be in multiple states or places at the same time? And to do that, he resorted to general relativity, where Einstein had equated matter with curvature in space-time. This is for large things like the sun and planets and so forth. Roger applied the same concept to tiny particles, quantum particles, so that an oscillating particle, say going between here and here, I don't know if you can see that, is actually two different space-time curvature oscillating between two positions. So that's, and then a superposition would be a separation. So you have the same particle in two locations and two space-time curvatures. So then what happens? That's debatable. Some people say that collapse occurs by consciousness causing quantum state reduction. This goes back to Bohr, von Neumann, Wigner, Stab, Dave Chalmers, Kelvin McQueen, usually known as the Copenhagen interpretation after Niels Bohr, where consciousness, shown here as being, observes and causes the collapse, causes this one to cease and selects this one. I call this subjective reduction because you have a subjective person, conscious observer, but it's dualist. It puts consciousness outside science, and that's okay if you're a dualist. Another possibility is the many worlds, where the separations bifurcate and each one goes off and forms its own new universe. And some people think that consciousness occurs at this bifurcation, including Hartmut Nevin, who'll speak this afternoon, and he would say that it occurs at this bifurcation. So maybe we'll put a bing there one of these days for that one. Penrose, however, said that superposition separation is unstable, will self-collapse, undergo objective reduction at time t equals h bar over e sub g, which is a form of the uncertainty principle. And bing happens when this occurs. And it happens along with a moment of conscious experience. So this is the Penrose proposed origin of consciousness, and I think the most scientific and specific theory of how consciousness is formed that's ever been put forth. So rather than consciousness causing collapse occurs spontaneously due to this equation. And when George Musser writes about putting ourselves in the equation, this is the equation, I would say. So rather than consciousness causing collapse causes or is consciousness due to this reduction. Now these, in the random microenvironment, these would be, which might be the same as decoherence, these OR events would be isolated and lack meaning and context. They would be proto-conscious or Whitehead simple occasions of experience. Metaphorically, these might be considered like the sounds of musicians independently tuning their instruments. How could they be organized, orchestrated in the brain for full, rich, conscious experience? How does it get turned into music? So Roger needed after he wrote his book, The Emperor's New Mind, he needed a quantum device which could biologically orchestrate quantum information, halt, terminate by Penrose OR, connecting to space-time geometry, non-computable Platonic values, and qualia, awareness and feelings, and regulate functional neuronal and synaptic activities. And I suggested microtubules, and he liked the idea, and we developed our theory of OR, orchestrated objective reduction, in the mid-1990s. So if we look at a microtubule, it's made of these tubulins. So this is one tubulin, look at an atomic level, and we see that it has 86 aromatic amino acids. So if you look up top there, tryptophan, phenylalanine, and tyrosine have these aromatic rings. You can see the rings with the 3 lines, or the 3 and then the 5-sided ring. That's an indole ring in tryptophan, and these are basically organic chemistry. And they also form quantum-friendly regions inside tubulin proteins due to these aromatic rings. And 86 is an awful lot for one protein. People, protein chemists are pretty startled by this. We can also see the anesthetic binding site in the sphere. This is where the anesthetic binds to prevent consciousness, and you can see it's right in the middle of all these aromatic rings where we think the quantum optical effects are happening, which lead to the quantum effects, which lead to collapse, which lead to consciousness. So there's quantum-friendly regions around aromatic rings. So a little bit of organic chemistry. In the 18th century, they had these, they knew about alkanes, which are linear molecules with or without a double bond. So they had the formula CnH2n plus 2, or CnH2n. And they also had this molecule C6H6, but they didn't know what the structure was. It was oily, flammable, and they called it benzene, but they didn't know the structure. And then, like the Ouroboros, and he woke up and said benzene is a ring, and he was correct. And on the far right, you can see another way to show with 3 lines, which can resonate between these 3 and the three opposite positions in a resonance situation. So what happens actually is that these rings share 3 delocalized pi orbital electrons among 6 carbons, forming these pi resonance clouds, which are basically superpositions. They're bulk of electrons being everywhere at the same time. And these support quantum electric and magnetic dipole oscillations, excitons, spin transfer, phonons, fluorescence, phosphorescence, superradiance. These are quantum effects. So in and around these aromatic rings, as long as they're spatially arrayed or in a geometric lattice, you can support quantum effects even at ambient temperatures. Back in 20 years ago, Ouyang and Aushalom did this study with these quantum dots and connected by aromatic rings, and they showed that spin transfer from dot to dot through the rings was enhanced by temperature. The warmer it was, the more efficient the spin transfer. So here's the quantum effect that's actually potentiated and promoted by heat. And also fluorescence, where you excite the tryptophan, for example, or one of the other aromatic rings, they kind of bubbles along in different quantum states and then collapses or emits the fluorescence. And you can measure the time in between the excitation and emission and how far it spreads. So this is another quantum optical effect. If we just look at the aromatic rings, if you leave them alone, they attract each other, even though they're uncharged, neutral, and chemically inert. And that's because the electrons in one, shown here as the shaded area, repel the electrons in the other. So you get two dipoles. So here we have two dipoles, like little bar magnets, which attract each other. And then they start to oscillate, and they oscillate in the terahertz. So this is where the terahertz comes from these aromatic rings being in the right position and then oscillating back and forth. This is the origin of the terahertz, which gives rise to the other ones as well. And you can have a superposition of both, which gives you a qubit from two aromatic rings. And we know that anesthesia works at this level by forming its own dipole dispersion forces and blocking the oscillation. So I think this is the mechanism of anesthesia. Of course, then you have to say in which protein, and we'll get to that. It should also be mentioned that psychoactive molecules, the neurotransmitter dopamine and serotonin, the pleasure molecule, the mood molecule, as well as psychedelics, all have complex, at least in the psychedelic, complex aromatic rings with five-sided along with the six-sided, and this has effects on consciousness, of course. So we developed a model based on the aromatic rings in here lining up in different directions, so we could have dipole through the tubulin, and it's basically a quantum channel, and that channel can go through each tubulin to the next, and form these helical pathways around in this case the 5-star helix in the microtubule, but could also go to the 8-star or other ways. So this is a qubit which extends mesoscopically or macroscopically because it goes the whole length of the microtubule. And when you have enough superposition, you reach threshold at time t equals h bar over e sub g. You have a bing moment, and then you start all over with a new set of initial conditions selected by the collapse process. This is just one piece of one microtubule, but you need a lot of these to have a significant effect in the brain. But it gives you a sequence of bings, and I think consciousness is a sequence of discrete events, discrete moments, like frames in a video or a film are discrete moments, but they appear like a continuum. And I think that's the same thing with consciousness. It's a sequence of events. We can quantify this a little bit. There are about 10 to the 9th tubulins per neuron, 10 to the 20th tubulins in the brain. We need it if we had 10 to the 15th tubulins, which is about a 10,000th or 100,000th of the brain, we would reach threshold at time t equals 10 to the minus 7 seconds. This is 10 megahertz, and we know 10 megahertz occurs in microtubules, and it's a favorably short decoherence time. So the quantum state can last that long. But it's also too fast for cognitive epochs and gestalt scenes of several hundred milliseconds. And for that, we need interference patterns to resonate and interfere across scale from terahertz to gigahertz to megahertz to kilohertz and slower. And the EEG may be interference beats of much faster stuff going on at a deeper level. If we think about what this means for different organisms, we have about upper right, I don't know, I think I burned this out, but human maximum is about 10 to the 20th, which would be about 10 to the 13th cycles per second. So over here we have the intensity of the experience, which is proportional to the frequency, kind of like a photon. The higher the frequency, the more energy. And so the higher the frequency, the more intense the experience. And down here we have the number of tubulins, the content complexity, so the possible content. And we can see on well, this is just based on tubulins, so it's going to be linear, but human, mouse, cerebral organoids, C. elegans, paramecium, and even plants might have a conscious moment every few seconds, for example, maybe a couple of minutes, whereas we have probably 10 million per second.